All right, welcome to Chapter 13, Section 4, called Rhombi and Squares. This is for Integrated Math 1, or IM 1. All right, so just to get started here on the front screen, the first thing you should see is your due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. We always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is one you get to keep. And partial credit is enabled, so if you answer one of two questions correctly, you get credit for the one question, or however many you answered correctly. This also, if I understand correctly, goes into parts of a question too, if there's more than one answer within the question. There's partial on there too. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. And what that means is once I click start, down here in the bottom right corner, there's going to be a submit assignment button. This is how we finish an assignment. So what that means on the last screen is you can't work on anything because Alex is going to lock all of your other assignments and even the resources until you click the submit assignment button. What it's trying to do is leave this attempt open for you and not close it. If you say close this screen and you're not done yet, or you close your computer, it's trying to leave the attempt open for you. So just make sure that when you want to leave this screen, whether or not you finished, you click submit assignment so that Alex doesn't lock out all of your other assignments and resources. That's one huge reason to click that button. Another big one is that it actually affects the gradebook when you click that button so that your teacher can see what you've been working on and hopefully it will improve your grade there. All right, on the side we always have three resources. We have explanation. Explanation tells us that we're going to lose our current question attempt, because it's going to give us the answer to this exact problem. So it's not going to give you the answers unless you come type them in. Example will give you something very similar to what it is we're looking at and kind of walk you through the idea here. Read through background information, especially if you see this section. If you don't see the background information, it's kind of introducing something brand new. That's the idea. So you can scroll through. Once you're happy with that example, you can close it. You can open another example so that you can see another one worked through if you need to. You can also message your teacher directly from the screen so we know where to come help you, because it attaches a picture of this problem on the email. So it's a good way to get specific help on a problem. All right, let's go ahead and get started. Okay. The Venn diagram shows the memberships for Math Club and Science Club. Use the diagram to show, to answer the questions below. So we have Math Club here, Science Club here, and this is both. So these three people are in both Math and Science Club. So how many members does the Science Club have? So we need to look at the entire circle for Science Club. So we have these four that are only in Science, but we also have these three that are in both. So that's 7 total. How many students are members of both Math Club and Science Club? So that's our middle, because it's and. So that's, got to scooch down here. 3. How many students are in the Science Club but not in the Math Club? So we want Science but not in the Math. So only the 4 that are off to the side there and only the Science Club. All right, let's go ahead and check. Yay, we got it. Okay, we're almost halfway there. All right, so this one says answer the questions about the figures below. And with this one, we have parallelograms, rectangles, and rhombi, or squares, actually, just squares. It doesn't say rhombi on the description. So we can see parallelograms, rectangles, squares, and that's actually what this title is called, identifying those 3 things. So which figures are parallelograms? So remember, and I can even open this real quick, because I have this guy here. There we go. So this was from a couple sections ago when I wrote this up. So all of these things come from the word parallelogram. If I know it's a parallelogram, I know all of these markings are true, which is opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, the diagonals bisect each other, consecutive angles are supplementary, which means they add up to 180. There's all kinds of things that come with the word parallelogram. To prove that it's a parallelogram, I can use one of these 5 pieces here. So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, the diagonals bisect each other, or we have one side that's congruent and parallel. So it has to be the same side. It could have also been the left and right side. I just drew the diagram top to bottom on this one. So we just want to look at this one and take a look and say, okay, well, number 1, it needs to be quadrilateral. It needs to have 4 sides. That's the main definition of parallelogram. It's a 4-sided figure that has one of these properties. The definition is a 4-sided or quadrilateral that has opposite sides parallel, but we can prove one of these other pieces. So this is 4-sided, and opposite sides are congruent. So figure A works as a parallelogram. If I look at figure B, I can see that we're not going to have opposite sides parallel here. That's not going to work. And the opposite sides are not what we would call congruent, because 4 and 2 doesn't work. 4 and 2 doesn't work like this. So that's not going to be a parallelogram. On this one, we do have a 4-sided figure again, and opposite sides again are congruent. So figure C also works. If you notice, I can click more than one. I can see that there are these little square features, which means I can click more than one. If they were circles, that would mean I would click a single one. All right, so which figures are rectangles? So remember, rectangles are special parallelograms that have right angles, so all 4 right angles. And the other bit, the bit that's special about rectangles, which doesn't come up in this diagram, but I've seen it in other diagrams, is that the diagonals are not only bisecting each other, but they are congruent in a rectangle. So if we have 4 right angles on a parallelogram, I already know it's a parallelogram, and I have 4 right angles, that is a rectangle. I don't have right angles on the other 2, so those will not be rectangles. Squares, well, I can kind of obviously see none of these are squares. A square has the same properties as a rectangle, except it also has congruent sides. So it's kind of a step down. So parallelogram goes to rectangle, rectangle can go to square. So we can say that a square is a rectangle, but we cannot say a rectangle is a square. We can't, because a rectangle doesn't have all 4 sides congruent. We have 2 long sides and 2 short sides. So we would say none of these figures work for a square. So this is what we call a kite. If that, I believe that comes up in a little while. A kite has consecutive sides that are congruent. So 4 and 4 and then 2 and 2, like that. And it has some other properties that go with it as well. But we call this one a kite, not a rhombus. A rhombus, square is a rhombus, where all 4 sides are congruent, and it is a parallelogram. A rhombi is just another special parallelogram. Okay. Did they give us? They do. Okay, so this is the diagram that I have on the notes page, and I really like this one because it kind of shows you the progression, or like the flow chart for these ones. So we have quadrilaterals. A trapezoid is a quadrilateral. It's a 4-sided figure, but only one pair of opposite sides is congruent in a trapezoid. So a lot of the time it's drawn like this, where you can see top and bottom are congruent, or not congruent, sorry, but parallel. These do look congruent on the side, but that's not a requirement. I could have drawn this side straight down. It could be a right angle here, and it would still be called a trapezoid. As long as one pair of sides is parallel, it's a trapezoid. And then parallelogram, so the basic idea is we have 2 pairs of parallel sides. And then we go into the special idea of rectangle or rhombus. So rectangle has 2 pair of parallel sides, just like a parallelogram, but it also has 4 right angles. A rhombus has 2 pair of parallel sides, just like a parallelogram, because it is a parallelogram, but now it has all congruent sides. So that's what's special about it. And then these both drop down into square, because a square has 4 right angles and all sides congruent. So a square is a rectangle and a rhombus. It's both, but we can't say a rectangle is a square. We can't say a rhombus is a rectangle in any way. That's not how they work. It kind of flows down to the square. So square is both of these, but these 2 are not both each other. Hopefully that makes sense. And not all rhombus or rhombi are squares. Sometimes they're kind of diamond looking like this one. Okay, so now we're going to go through and we're going to use these facts to fill in that chart. So all sides are congruent. For a parallelogram, that's not always true. So remember, you want to make sure that it has to be always true. It can be true, but it's not always true. Two pair of parallel sides, that's true for a parallelogram, a rectangle, and a rhombus. All three of them have to have those two pairs of parallel sides because they're all parallelograms. One pair of parallel sides, that would only work if you saw trapezoid. I don't see trapezoid there. So the all sides congruent, that fit into the rhombus category. So this, I'm not going to click any. And then all, or four right angles. So the only one that would fit here would be rectangle. If I saw square, I would also click square. Alrighty. Alright, so on this one, we're just going to state true or false for these statements about a quadrilateral or a parallelogram. So these are all the special parallelograms. We're just deciding which is true and false about each piece. So every parallelogram is a square. Well, the best way to do this is to kind of come up with a situation that is not true. So if I can draw, so if I draw a rectangle, well, a rectangle is a parallelogram, right? We know that. This is one of our special parallelograms, but it is not a square, right? A square has all the same sides, but it is also a parallelogram. So not every parallelogram is a square, but every square is a parallelogram. I can say it the other way there. So this would be false. Every rectangle with four right sides is a square. With four congruent sides. I said that funny. Four congruent sides. So if it's a rectangle and it has four congruent sides, it would be a square. So using the two pieces we have here, a normal rectangle, kind of what we picture, has two long sides and two short sides. But if it has four congruent sides, well, what a rectangle is just a parallelogram that has four right angles. So a square is a rectangle. Not all square or rectangles are squares, but all squares are rectangles. So it's just one of those things you have to make sure you think through it. A square does fit into the definition of rectangle. So every quadrilateral is a rhombus. Well, is that true? You know, a rhombus is actually kind of the square shape, not specifically. It can be kind of a diamond. I'm not doing that very well, but let's see if I can draw a diamond nicely. That kind of just looks like a square sideways, but it's a little bit more rectangle-y. But it can be a diamond shape where it's not really a square. A rhombus just has four congruent sides. It's a parallelogram with four congruent sides, but it doesn't require the 90 degrees like a square. So every quadrilateral would not be a rhombus because this is a quadrilateral, this rectangle up here. Or I could have, kind of the basic parallelogram shape we started with before. That's not a special parallelogram, just a regular one. And I know I drew those kind of curved, but this is a parallelogram. It's quadrilateral. It has four sides, but it is not a rhombus. It does not have four congruent sides. So this would be false. Every rectangle is a rhombus. Well, again, that's, the idea. Every square is a rectangle, but we can't say every rectangle is a square. And a rhombus would fit into square. So remember, rhombus means it has four congruent sides. Well, this rectangle cannot do that. It doesn't go to that direction. But if it's a square, then it could be called a rectangle. So it's just kind of thinking about, the progression of these things and going back and forth and making sure that you understand the features of each one of the special parallelograms. So I'm going to go ahead and cancel. I just want a new one. I don't want to close it. All right. So for the rhombus below, find the measure of angle 1, 2, 3, and 4. So we have a rhombus. We don't necessarily know that it's a square, but we do know that it has some special qualities to it here. 1, 4, and 3. So we're given that this angle here is 44 degrees. Remember, if it says rhombus, I know that everything before that was true. And what I mean by before that is if I was looking at that diagram again, everything that's true for a parallelogram is true for a rhombus. A rhombus also has congruent sides all the way around. This one looks somewhat square, but we're not going to necessarily, promise that it's a square. All right, so with this one, we have, for this piece, let's see, we're going to go down and we're going to fill this piece in. So the other bit for a rhombus, which I'm going to go ahead and click on the example because it does tell us this in the example. The background here is it's a parallelogram of 4 congruent sides. We know that, and this one even looks like a little bit more of a squished diamond. So the diagonals of rhombus are perpendicular. So that's another bit that we can kind of use here. Let's see. They bisect each vertex angle. So that's another very important piece. The diagonals of a rhombus also bisect the vertex angle. So if I know what one is, if it bisects it, the other side has to be the exact same thing, like that. And remember, opposite angles are congruent, so it's going to be the same, because this is a isosceles triangle. So I'm using that idea again of an isosceles triangle. I think we either use that on this video or the very last video. I can't remember. There's a couple very similar ideas we're using here over and over again. So because this angle is 44, so is this angle. So I've already filled in these two. I could have also used alternate exterior or interior angles here because I have parallel to a transversal, parallel to a transversal. So I know that they're both 44. And then to fill this piece in for the 3 here, I could either use consecutive angles add up to 180 or triangle angle sum theorem because I have 44, 44, and then a missing angle. And they have to add up to 180 degrees, all 3 of them. So I have 88 here, and so I can say, well, what have I used? I've used 88, so I'm just going to subtract, and let's see, that would be 92, right? So angle 3 here has to be 92 degrees. So just going through and understanding some of those pieces. So that diagram didn't quite show us the diagonals for a rhombus are a little bit more special where they bisect that angle. So that definitely changes things up a little bit. Oh, and I forgot angle 1. So angle 1, that's opposite of angle 3, so it's also going to be 92 degrees. So I have 92, angle 2 is 44, angle 3 was 92, and angle 4 was 44. All right, check. Perfect. Okay, so with this guy, we are going to be classifying parallelograms in a coordinate plane. So we're considering a parallelogram. We already know it's a parallelogram. It's already telling us that. So I'm going to go ahead and just get a new one here. Boom. Okay. So it tells us we have JKLM here, and it gives us the vertices. Answer the following to determine if a parallelogram is a rectangle, rhombus, square, or none of these. Well, it told us it's a parallelogram, right? We already know that. So if the parallelogram is either a rectangle, rhombus, or square, so we have to think about those pieces. For a rectangle, oops, why is it? Oh, because I don't have my pen on. For a rectangle, I would need to show, we already know it's a parallelogram, so all of those apply, but I would need to show that we have right angles, like this. I could also show that the diagonals were congruent. That would make it a rectangle, and it would also qualify as a square if all 4 sides are congruent. We'd have to go a little farther to determine if it's a rhombus, and then a square. So what it's going to have us do first is find the length of LM. So in order to do length, we need the distance formula again. We were doing this a little bit ago. I think it was on my last video, actually. So this guy should be on your notes pages. It's the distance formula. So we subtract the x's, we subtract the y's, we square those, add them together, and then take the square root. This actually comes directly from Pythagorean theorem, where we have a squared plus b squared equals c squared. So if I could actually draw down and over, so this right angle here, I would have A, B, and C. C is actually the length of JM. I know I didn't draw that perfect on here as far as the diagonal, the direction there, but it's just the picture. So I'd have A squared plus B squared. Well, A squared is the difference in Y, right? The change in y. B is the change in x because it's left or right. And then c, that's the distance we're looking for, so that's why it's d. But instead of d squared, what we're doing is we're taking the square root of the other side, so I just have d on this side. So it's just a little background. Where does the distance formula come from? It's Pythagorean theorem. All right, so we're going to go LM. So L is 7, negative 2. M is 5, negative 5. And we have, remember it's x, y, and it's 1, 1, x, y, 2, 2, and this just means 0.1, 0.2. So I have 5 minus 7 squared plus negative 5 minus negative 2. Make sure you leave this minus. It's part of the equation here, so that doesn't go away. So now I have 5 minus 7, that's negative 2, plus negative 5 plus 2. Minus negative turns into a plus. So I end up with negative 3. So now I have 4 plus 9. That gives me 13. So I come over here and I'm going to go square root 13. And now I'm going to find the side length, the length of a side adjacent to LM. So for LM, they don't care if it's JM or KL. You get to choose. It just said a side adjacent to it, meaning right next to it. So they don't want the opposite side. They want a side right next to it. What we're doing is we're testing, are the consecutive sides congruent? If the consecutive sides were congruent, which I can kind of obviously see that they're not, but if they were, that means that it would go into a rhombus. If we already have a parallelogram and consecutive sides are congruent, it is a rhombus. So we're just checking that real quick. So I know it's not going to work out correctly, but I have to fill this in. Alex is going to require it. So let's see, J, and I just picked JM for this one. It wouldn't matter which one you did. If you did JM or the top one, which is KL, negative 1, M is, so that's, I wrote that in the wrong spot. I scribbled that out, but that was me writing it in the wrong spot. That was supposed to be there. Negative 1, and then M, 5, negative 5. All right, so I have 5 minus negative 5 plus negative 5 minus negative 1. I think I said minus negative 5, minus negative 1. I wrote it correctly anyway. All right. Both of these turn into plus signs. So I have 6 squared plus negative 4 squared. So I end up with 36 plus 16. So let's see, I end up with 12, 4, 5, 6, so 62. And I can't take any square roots out of that because it can divide by 2, but that would give me 31, so that doesn't help me at all. Oops, 62, not 32. So they're obviously not congruent. So it's not a rhombus, which means it's not a rectangle. But we can still see if it is a rectangle other than, you know, rhombus or square. We can check the slopes. So we want to check the slopes because we learned this. I actually think it might have been back in semester 1. If a line is perpendicular to another one, the slopes are going to be negative reciprocals. And what that means is if the slope of one is 2/3, the negative reciprocal, I would flip it over. And if it's positive, it becomes negative. If it was negative, this would become positive. That's all negative reciprocal means. We flip it over and we flip the sign. Okay, so we're going to check to see if that works. So slope is rise over run. So this is still the difference in y's, and it's the difference in x's, but we're just doing a division, a ratio here. All right, so we're going to have LM. So L was 7, negative 2, and M was 5, negative 5. And so we have y minus y over, minus, it was minus negative because it's the two negatives, and then 5 minus 7. So I end up with negative 3 over negative 2 Well, the two negatives are going to drop away. It's just going to be 3 over 2. That was actually a guess. I didn't mean to do the 3 over 2. I was just kind of guessing there. That's very silly. I did not mean to guess that slope there. All right, and then it says a side adjacent to LM. So let's go ahead and stick with JM here. Why not? So J is -1, -1. M was 5, -5, like that. All right, so now we're going to have y minus y over x minus x. So I'm going to have plus and plus, so I end up with -4 over +6. I do need to reduce this. It's going to stay negative because there's only one negative this time, but I can divide by 2, and I get 2. I can divide by 2, and I get 3. So I have these two pieces. So 3/2, 2/3, that's a reciprocal. I flipped it over. This was positive, this was negative. So just by chance, I kind of guessed at the fact that it was going to be 2 and 3. Oops. There we go. Hit too many times. So, don't click on that one. So because the slopes are negative reciprocals, LM is perpendicular to JM, which means this is a right angle. If I have a single right angle inside of a parallelogram, they are all right angles. And why is that true? Well, because if we think about a parallelogram, and that's a very horrible parallelogram. Goodness gracious, I can't do a parallelogram right now. Better. All right, so if we have this one angle here, that's a right angle, remember all the other pieces still work for this because it's a parallelogram. So opposite angles are congruent. So this is a right angle. Consecutive angles add up to 180. So that would be 90 and 90. These are also consecutive angles or opposite. So 90. So if I have a single 90-degree angle on a parallelogram, they are all 90s, which is the definition of a rectangle. I have to have 4 right angles. All right. Uh-oh. Which one did it not like? 5. Oh, it's 52. Silly me. That was silly. 52, not 62. Okay. It just didn't like my addition there. Do mistakes happen? Of course they do. Just go back, check your answers. I knew it's important to know that these aren't equal. It's not 100% important to know the exact answer. As long as I know that they're not equal to each other, then I know they're not rhombus or square. That's what we're checking for. But Alex wants me to make sure I did my math correctly. It wants me to type that in to show that, that I've proved that it's not a rhombus or a square. All right, so that was section 5. I will see you in section 6.